In this lesson, we're going to use trigonometry to find missing angles. And that is, given the ratio of the sides, we're going to go backwards and find the measure of the angle. So look at example 1. Say they tell you that sine of q equals 0.5878. And remember, that could be a fraction that was changed over to a decimal. And so it is a ratio of a side over a side written as a decimal instead. So what they want to know is if sine q equals 0.5878, what is the measure of angle q? Because remember, q always has an angle in that spot of right after sine. So what you're going to do is rewrite the problem, and we're trying to solve for q, but you can't just divide sine on both sides to get rid of q, because sine is a function that's being done to q. It's not being multiplied by q. And so because it's a function being done to q, we need to do the inverse function of it to get rid of the sine, basically. And so the way you want to think of that is there's something called the inverse sine, and that's the little -1 means the inverse operation, the inverse function. And so you'll see that a lot in different applications beyond trigonometry. But this means the inverse sine of sine of q. And so what the inverse sine does is it kind of undoes the sine. And so you're left just with q on the next step, because the inverse sine is the only thing that will undo a sine. And so to balance that out, you've got to inverse sine the other side of the equation. And notice I put it in the front of both of them, so I had to leave space to do that. And when you inverse sine both sides, you end up with these kind of undo each other, and you end up with q. And then this can be done on the calculator. If you look at your calculator key, the one that says sine on it, above it, it has inverse sine. And so that means you hit the second and then the sine button to get what's above the sine button. So we're going to hit sine -1. First, make sure your calculator is in degrees, because we're going to be putting this answer in degrees. If you want it in radians, it will also give you that. But if you've ever reset your calculator, it defaults back to radians a lot of times. So you need to go into mode and check to see that degrees is highlighted and not radians. But after you've got that figured out, then you do inverse sine and then 0.5878, and then push enter, and you'll get a degree measure. And the degree measure that I got was 36 degrees approximately. It was there were some decimal places after that, but we round to the nearest degree in this example. So angle Q, the measure of it is 36 degrees. So that's how you know something about the ratio of the sides, and you're asked to go backwards and find the angle. So now that we know what the inverse sine is, there's also one above the cosine button called inverse cosine, and one above the tan button called inverse tan. And so we can now take a picture like this in example 2, and if we're given a couple of sides, we can go backwards and find the angle measure. And so in this particular example, we want to find the measure of angle A. So first thing you want to do is, just like when we were finding sides, we want to figure out whose perspective we're coming from, and the angle that we want to come from is angle A. We want to use his perspective, and so because we're finding measure of angle A. So really all we care about is measure of angle A, and so we want to label our adjacent, opposite, and hypotenuse according to the perspective of angle A. Well, this one's always the hypotenuse because it's across from the right angle. Then opposite the A is over here, and so we call this side opposite, and then next to angle A is the adjacent. So you want to label those every time, just so you don't get confused of which sine, cosine, or tangent you're going to be able to use here. So since we were given information about the hypotenuse and about the adjacent, we want to use whichever trig ratio has adjacent and hypotenuse in it. And remember, SOHCAHTOA, the one that has the adjacent and the hypotenuse, is the cosine. So we go to cosine and write a statement. Cosine of an angle, and the angle we don't know this time, so we're just going to write A because that's the label for the angle. Cosine of angle A equals side over side, and remember it's adjacent over hypotenuse. So the adjacent is 39, the hypotenuse is 89, and that's our setup. So now we're asked to find angle A, so we want to take the inverse cosine of both sides. So rather than rewriting it, I just squeezed it in front of each one, and then know that the cosine undoes the inverse cosine undoes the cosine, and you're left with angle A. That's why we do it. And then you want to take the inverse cosine of 39 over 89. Make sure you put that fraction in parentheses. Inverse cosine of 39 over 89 on your calculator. And it comes out to be approximately 64 degrees. So that is the measure of angle A. On the third example, we're asked to find a different angle this time. Instead of A, we're asked to find angle B. And so we find angle B and label our three sides according to the perspective of looking out from angle B. So this one is always the hypotenuse across from the right angle. Then we've got across from the B is your opposite, and next to the B is your adjacent. Now we look at which pieces we have information about, or which two we choose to use, and we're going to choose to use these two because we don't have any information about the hypotenuse. If we did, we could choose which two sides we wanted if we had information about the hypotenuse as well. We could choose any two sides that we want and then decide which trig ratio goes with those two sides. But since we only have two sides, we're going to use those two sides for this example. So we've got an opposite and an adjacent, and if you think of SOHCAHTOA, you've got TOA is the opposite and adjacent one. So we're talking about tan. So tan of angle B, tangent of angle B is opposite over adjacent. So opposite is 32, adjacent is 34, and that's our setup. Now we're trying to solve for B, and so we need to inverse tan both sides to get rid of the tan. Can't divide the tan out, you have to inverse tan it because it's a function that needs to have an inverse function done to it. So I squeezed in an inverse tan in front of each of them, and the inverse tan of tan B is just B because the inverse tan undoes the tan and you're left with B. So here's B. And then the inverse tan of 32 over 34 you find on your calculator. So you hit the inverse tan button and then a parentheses 32 over 34 and then close your parentheses, and you should get approximately 43 degrees. And so that is the measure of angle B when the sides are 32 and 34 in the ratio that we had.